Hey everyone, and welcome. Today we're jumping right in to tackle one of Go's most powerful features, generics. If you're writing Go, this is something you absolutely need to get your head around. So let's get cooking and break down the recipe for some seriously reusable code. So let me ask you something. Have you ever found yourself writing a function that works perfectly for integers, and then you have to copy, paste, and change it just to work for floats, and then maybe do it all over again for strings? Yeah, it's a total pain, right? Well, that exact headache is the problem generics were born to solve. The easiest way to think about this is with a little analogy. Imagine you have a master recipe for a cake. Instead of needing a separate recipe for a cake made with all-purpose flour, another for whole wheat, and a third for almond flour, you just have one. This one master recipe simply says add 1 cup of flour, and you get to decide which kind to swap in. That, right there, is the beautiful simplicity behind generics. Okay, so let's get a little more formal. What exactly are generics? Well, they were officially introduced back in Go 1.18, and they're a way to write code that isn't hard-coded to one specific type. What that really means for us is that we can build functions and even entire data structures that are way more flexible and reusable, working across a whole family of types without breaking a sweat. All right, so you're probably wondering, how does this magic actually work under the hood? It really just boils down to two core ingredients. Let's break them down. First up, we've got the type parameter. The best way to think of this is just as a placeholder. It's a stand-in for a real type that we'll provide later. You'll always see it declared in square brackets, usually with a capital letter like T. So going back to our cake recipe, this T is literally the placeholder where we say, hey, this is where the type of flour goes. And the second crucial ingredient, the type constraint. Now, this is what keeps everything safe. A constraint is just an interface that sets the rules for our placeholder. It's our recipe telling us, look, you can use any kind of flour you want as long as it's actually, a grain flour. This guarantees that whatever type we plug in will have the methods and behaviors our function needs to work correctly. No trying to bake a cake with sand. And this is where it gets really powerful because you have a ton of flexibility. You can use the built-in constraint called any, which is the wildcard. It lets literally any type through. Or you can define your own custom constraints for very specific rules. And my personal favorite, you can use the super handy constraints package, which gives you pre-built rules for common things like all integer types, all float types, or any type that can be ordered. Okay, theory is great, but let's see this stuff in the real world. How does this all come together in actual code, and where are you going to find yourself using it day to day? One of the most common places you'll see generics is in, well, generic functions. Let's take a classic example, like a function to find the minimum of two values. You can't just allow any type in there, right? I mean, how do you use the less than symbol on two custom structs? You can't, and that's exactly why you'd use a constraint like constraints.ordered. It's a signal to the Go compiler that this function will only accept types that can actually be compared. In this next one, this is a huge one, generic data structures. Thanks to generics, you can now write a stack, or a queue, or a linked list just one time. And that one implementation can hold integers or strings or whatever custom struct you can dream of. It means we can finally say goodbye to writing an int stack, a string stack, a user stack. You get the idea. It's a game changer. Now, for anyone who's been writing Go since before version 1.118, this right here is the absolute killer feature, the big payoff. Generics give us compile time type safety. Before, we had to use empty interfaces, interface/, and then do these messy, slow, and error-prone type checks while the program was running. With generics, the compiler checks everything for you before you even run the code. It's faster, it's safer, and honestly, it helps you sleep better at night. Okay, so let's level up the conversation a bit, because this is where we start thinking like a senior engineer. Generics are incredibly powerful, but they aren't a silver bullet. They don't replace interfaces. Knowing when to reach for generics and when a good old-fashioned interface is still the right tool for the job, that's the key. I really want you to let this quote sink in, because it is the absolute heart of the matter. Interfaces are about abstracting behavior, what a thing can do. Generics, on the other hand, are about abstracting types, what a thing is. It's a subtle difference, but it's absolutely fundamental. So let's make that really practical. You're going to reach for generics when the logic is identical for different types. Think of data structures like slices or maps. The algorithm is the same no matter what's inside. You'll want to stick with interfaces, however, when different types all share a common capability, but they each implement it in their own unique way. Think of the standard library's writer interface. A file and a network connection are completely different types, but they both know how to behave like a writer. See the difference? So just to hammer this home, what's the sweet spot for generics? Well, number one, writing those general-purpose data structures. Number two, writing utility functions that work on collections, like merging channels or mapping a function over a slice. And number three, implementing common algorithms, like a sum function that works on a whole family of number types.
Whew! Okay, we've covered a lot of ground here, from the basic kitchen ingredients all the way up to the high-level strategic decisions. So let's boil this all down to the one main thing you should take away.
At the end of the day, generics are not just some fancy new syntax. They are a fundamental tool for writing better Go code, code that is cleaner, much safer, and dramatically more reusable. They let you finally stop repeating yourself and start building truly robust, flexible software. So we've handed you the recipe. The only question left is, what are you going to go build with it?